All right, let's dive right into this explainer. We're going to take this somewhat abstract world of Python data types and give you a highly tangible mental model. How? By stepping into a brand new, completely empty kitchen that is just waiting for a massive grocery delivery. So picture this. Your counters are absolutely bare. The delivery truck just pulled up, and all of your programming data, the numbers, the text, the giant shopping lists, are the groceries that need to be put away and organized perfectly. You obviously can't just throw everything into one massive pile in the center of the room, right? You need a system. You need the absolute right containers for the right ingredients.
Setting the scene, the Python kitchen.
To keep everything from turning into a total chaotic mess on the counter, we have to start with the fundamentals. First up, variables. In programming, variables are simply the physical containers you rely on to hold your data. Whenever you hear someone talk about declaring a variable, I just want you to picture them reaching into a cabinet and pulling out an empty jar, a box, or a piece of Tupperware. That's really it. It's just an empty vessel waiting to hold an ingredient. Now, here is where data types come into play. Data types are the specific labels and the structural designs of those containers. Just like you wouldn't store piping hot soup in a flimsy cardboard box or a single dry bay leaf in a massive 5-gallon jug, different programming data requires specifically designed containers to actually function properly. And what's super cool here is how smart Python actually is. In a lot of programming languages, you have to meticulously label every single jar yourself before you can put anything inside. Not here. Python uses something called dynamic typing, acting like a highly intuitive kitchen assistant. The exact second you pour an ingredient into a container, Python instantly looks at it and says, that's sugar, so this must be a sugar jar. It guesses the exact container type for you perfectly. Let's move on to the basics, single-item containers. These primitive types are built to hold just one single value at a time. If you're dealing with numbers in your code, I want you to think of your containers as your trusty measuring cups. But Python is very particular about how it measures things, separating them into two distinct categories based entirely on precision. So an int, or integer, is a whole number. Think of it as scooping exactly 4 whole cups of flour. But a floating point number, has a decimal point. It's 4.5 cups of water. Now, why does Python care? Well, because a recipe with 4 cups of water turns out vastly different than a recipe with 4.5 cups. Mixing up an int and a float can completely ruin your programming recipe. Okay, what about text? For words and characters, Python uses strings, which we abbreviate as str. Think of a string as a roll of label tape in your kitchen. In Python, we always wrap our text in quotation marks. You can imagine those quotes as the actual act of peeling a piece of tape off the roll and sticking it right down onto a jar. It's how Python knows for absolute certainty that it is looking at the word salt and not a numeric value. Then we have Booleans, abbreviated as bool. These are incredibly simple, but basically the foundation of coding. A Boolean is exactly like your pantry light switch. It is either true, meaning the light is on, or it is false, meaning the light is off. There is absolutely no in-between here, no dimmer switch. It's completely binary, and we use it constantly in coding to make yes or no decisions. Next up, the pantry. Multi-item containers. So what happens when you have, say, 20 loose apples? You can't just throw them onto the counter and expect things to run smoothly. You need collection containers. Let's look at 2 common ones side by side. A list is like a highly flexible spice rack. Every slot is numbered, slot 0, slot 1, slot 2. You can easily take cumin out of slot 1 and swap in paprika. It's mutable, meaning you can change it. And yeah, it allows duplicates. But a tuple? A tuple is like a factory-sealed egg carton. It's also ordered, but it is immutable. You absolutely cannot safely pop a hard-boiled egg into one of those plastic slots or change its size without breaking the entire structure. Once a tuple is made, it is locked in for good. Now, if you find yourself in a situation where you really don't care about the specific order of things, you can use a set. A set is basically like having a giant magical fruit bowl sitting right there on your counter. And the crucial point here is understanding the magic of this particular bowl. When you toss fruits in, they just roll around randomly. There's no slot 1 or slot 2. But more importantly, it only holds unique items. If you already have a green apple in the bowl and you try to toss a second identical green apple in, it magically vanishes. Sets are the absolute best way in Python to instantly filter out duplicates from a massive pile of data. Finally, in our multi-item pantry, we have the dictionary, or dict. Think of this as your premium cubby organizer. But unlike our list or our spice rack, this organizer relies on specific name tags rather than numbered slots. It maps a key to a value. The key is the specific label on the outside of the cubby, like the word sugar. The value is what is actually stored inside, the literal bag of sugar. This is incredibly efficient because you don't have to hunt around asking, wait, did I put the sugar in slot 3 or slot 4? You just look directly for the label sugar and grab what's inside.
Let's finish up with the final taste test.
Let's do a super quick lightning round to see how these physical containers translate into real data scenarios. First scenario for you. If I want to store a student's final grade percentage of 92.5%, which container type am I reaching for? Think back to our measuring cups and that very important decimal point. You guessed it, because of the decimal point, it requires a float container. An integer container would just lop off the 0.5 entirely, giving the student a 92, which honestly might drop their letter grade. We need the precision of a float, just like needing exactly 4.5 cups of water. Okay, scenario 2. What if you want to store a sequence of system usernames and, for security reasons, it is absolutely critical that they cannot be altered, added to, or removed later? Consider which multi-item container has a strict security seal to prevent meddling. You'd use a tuple for sure. By leveraging that factory-sealed immutability, those usernames are completely locked in. If a hacker tries to treat it like a list and swap a username out, the program will just throw an error and refuse the change, keeping your data totally safe. And there you have it. With variables acting as your sturdy containers and data types functioning as your highly specific labels and structural designs, your basic pantry is fully stocked and organized. The chaos is gone and the logic is clear. So I'll leave you with this question to ponder. Now that you completely understand the tools at your disposal, what complex, amazing recipes are you going to start cooking up in your own Python kitchen?